Hello, welcome back to Math 8. This is a video over Section 6, and what we're going to be doing today is we're going to be analyzing solutions. So there are different types of solutions that we'll get. Sometimes we'll have one solution. All the problems that we have done up until this point have yielded us one solution. Sometimes we get infinitely many solutions, and sometimes we get no solutions, okay? And then so we have to solve those, then your ability to identify those equations, okay, and then write equations that have infinitely many solutions or no solutions, okay? So here's the idea, okay? And so when we identify these different types of solutions, okay, we solve or simplify each side of a linear equation, okay? If we see that we have a different variable on each side, different variable term, we have one solution. If we have the same variable term on each side, okay, then we have two options. If the same constant, we have infinitely many solutions. If we have a different constant, we have no solutions. Okay, I'll tell you what that looks like. There are also ways to go about this and, continue to solve down to the very end. And this is typically what I like to do. Okay, and so if you get x equals a number, okay, a is a number. All right, let's write that. A is a number. Okay, so if a is a number, x equals a number, that means that you have one solution, okay? So that's one solution, okay? If you get down and you solve an equation and all of a sudden your variable terms get eliminated and you get a true statement where like a equals a, equation is true for any value of the variable, this means that you have an infinite solutions, okay? Infinite solutions. Okay. On the other side of this, if you have a equals some number b, where you have a false statement, okay, so there's no value for the variable that make a equal to b, okay, then you have no solution. All right. So rule of thumb, okay, x equals a number, you're good. You have one solution. If you get a true statement, you have infinite solutions. If you have a false statement, you have no solutions, okay? And so what I'm going to do is go through each of these problems to show you what we get, okay? So let's take a look at this first one. 2 times 2x plus 10 is equal to 4 times the quantity x minus 5 and then plus 6. So let's solve this for x. Okay, so same thing. Distribute our 2, all right, and then distribute our 4. So we get 2 times 2x plus 2 times 10 is equal to 4 times x plus 4 times negative 5 and then plus 6. Okay, so 2 times 2x gives me 4x. 2 times 10 is plus 20 is equal to 4x, okay? And then 4 times negative 5 is negative 20 and then plus 6. Okay, so let's simplify this right side. So I got 4x plus 20 is equal to 4x minus 14. So notice here that you have the same variable term, okay? And notice that your constants are different. Simply by seeing this, I already know that we're going to have no solution, okay? And so let's do this, all right? Let's combine our like terms here. So I'm going to take this 4x, I'm going to move it to the other side. Now when I do that, this is where you guys get confused. Because if I subtract 4x, all of a sudden, your x's have canceled out, and you don't have any x's anymore, okay? You simply have a statement that says that the number 20 is equal to the number 14. And guys, that is simply just not true. This is false, okay? Therefore, if you get a false statement, you have no solution, okay? Now, let's go back up to this step here where you got 4x plus 20 is equal to 4x minus 14, okay? Let's just let x equal 1, okay? Let's just see what happens. So if I let x equal 1, I plug that in. 4 times 1 plus 20 is equal to 4 times 1 minus 14. So I get 4 plus 20 is equal to 4 minus 14. Okay, 4 plus 20 is going to give me 24. Okay, and then 4 minus 14 gives me negative 10. This is still false. Okay, if I let x equal 2, all right, let's just let x equal 2, all right, 4 times 2 plus 20 is equal to 4 times 2 minus 14. So I get 8 plus 20 is equal to 8 minus 14. Okay, so I get 8 plus 20, that's 28, is equal to 8 minus 14, and that's going to give us negative 6. This is still a false statement. So the moral of the story is there is no value for x that will work, that will make this true. Okay, make this statement true. Okay, and that's the idea. Okay, so when you get to this point where you have a false statement right off the bat, okay, once you've canceled out your x's, there's no solution. Okay, and you can just stop there. Now, if you want to sit here and continue to plug in numbers and see if you get a true statement, you're always going to get a false statement. Okay, so you don't need to do that, but if you want to do that, be my guest. Okay, but let's take a look at the next one. Okay, because the next one's kind of an interesting problem. So let's take a look at 9 times x minus 2 equals 9x minus 18. So I'm going to do 9 times x plus 9 times negative 2. All right, and that's going to equal 9x minus 18. Now, 9 times negative 2, that's going to give me negative 18. So look what I've got. I've got 9x minus 18 is equal to 9x minus 18. Notice that right off the bat here, you have the same thing on either side of the equal sign. Okay, this, I know we're going to have a true statement. I have the same variable term and I have the same constant term. Okay, now watch what happens. If I subtract 9x from both sides, these are going to cancel out and you're going to be left with negative 18 is equal to negative 18. Because these numbers are the same, negative 18 is equal to negative 18, this is a true statement. Okay, therefore, we have infinite solutions. Okay, and that's the idea. Okay, I've got infinite solutions here. So any number for x will work. Okay, so now let's try this. Let's just let x equal 1. Okay, if I do 9 times 1 minus 18, is that going to equal 9 times 1 minus 18? All right, and the answer to that is I get 9 minus 18 is equal to 9 minus 18. 9 minus 18 gives me negative 9, and I get negative 9 over here. That's true. We're good. Boom. X equals 1 is the solution. Well, heck, let's try x equals 2. All right, so let's let x equal 2. All right, so I got 9 times 2 minus 18 is equal to 9 times 2 minus 18. All right, so 9 times 2 is going to give me 18 minus 18. All right, and then I've got 9 times 2 is 18 minus 18. Oh, look. We get 0 equals 0. That's a true statement. Notice how I've plugged in two different numbers, okay, and they give me true statements, where over here, they kept giving me false statements. That's because the answer to this equation is there is no solution. Over here, we have an infinite number of solutions for this equation, okay? So it really just kind of depends, all right? So let's take a look at the next one. 8x minus 4 minus 2x equals 2 times 5x minus 2. So let's take this 2 over here. Let's distribute it. So we're going to get 2 times 5x plus 2 times negative 2. All right, and I've got 8x minus 4 minus 2x. So 8x minus 2x, that's going to give me 6x minus 4. Okay, over here, I've got 2 times 5x, which gives me 10x, and then minus 4. Okay, and that's okay. Now notice over here, we have different variable terms, but our constant terms are the same. All right, and oftentimes this will kind of confuse you as well. But let's go ahead and do this. I'm going to move my 6x over to the right side. So I'm going to subtract 6x over here and here. So I've got negative 4 is equal to 4x minus 4. Now I'm going to add 4 to both sides, add 4 to both sides, and check out what I get. All right, these are going to cancel out. These are going to cancel out. So I'm going to get 0 over here. Negative 4 plus 4 is 0 is equal to 4x. Now, what I'm going to do, I have 4 times some number gives me 0. What's that number? Well, the answer is going to be x equals 0. Okay, what makes this equation true? Now, if I divide both sides by 4, all right, the 4's divide out to 1, so we're left with x. 0 divided by 4 gives me 0. And that's my answer for x. Okay, so this one we do just have one solution where it's just x equals 0. Okay. All right, now let's go ahead and let's take a look at this next one. All right, use the properties of equality to solve this equation. So I'm going to distribute my 3. All right, so I've got 3 times x plus 3 times 6. Distribute my 2. So I've got 2 times x plus 2 times negative 3, and then plus 4x. All right, so 3 times x, 3x. 3 times 6 is plus 18, is equal to 2x minus 6 plus 4x. Okay, and so at this point, let's combine our like terms. All right, I've got 3x plus 18 is equal to, what is that? 2x plus 4x is 6x minus 6. Okay, now what I'm going to do, I'm going to move my 3x over to the right side. So I'm going to subtract 3x from both sides. Okay, so that's going to cancel out. I've got 18 is equal to 3x minus 6. So I'm going to add 6 to both sides. All right. And that's going to give me a value of 24. So I've got 24 is equal to 3x, divide by 3, and we get x is equal to 8. So I got x equals a number, so we're good, okay? And we don't need to do anything else from that point, okay? Because we just got x equals a number, and we're good. All right, take a look at the next page. Okay, over here, let's take a look over here. I'm going to distribute my 8. Let's solve this equation. Moving kind of quick. All right, so I'm going to do 8 times x plus 8 times 4. Okay, over here, I'm going to do 4 times x. So 4 times x plus 8 times 4. I'm sorry, 4 times 8. Doesn't really matter, but let's keep that straight. And then plus 4x. Okay, so 8x, and then 8 times 4 is 32. Okay, and then I've got 4x plus 32 plus 4x. Okay, so then here my like terms are 4x and 4x. I'm going to combine those to give me 8x plus 32, and that's going to give me 8x plus 32. Now what I notice is that the left side of my equation is the same as the right side. So we're going to have infinite solutions, but let's take a look. Let's cancel out our variable term. Let's subtract an 8x from both sides, move this one over here to the left, okay? And so that's going to cancel out. This is going to add to 0, cancel out. And then we're going to get 32 equals 32. This is a true statement. Therefore, we have infinite solutions, okay? And that's it, okay? We're just looking to see what we get. All right, take a look at this next one. Over here, I've got 5x minus 3. I'm going to distribute my 7 here. So 5x minus 3 is equal to 7x plus 7 times 4, and then minus 2x. So I've got 5x minus 3 is equal to 7x. Let's write this, 7x plus 14 minus 2x. Let's combine our like terms, 7x and negative 2x. So that's going to give me 5x plus 14 equals 5x minus 3. Now, what you need to realize is that we have the same variable term, but our constant terms are different. So what I'm going to do is I'm going to move my variable term over. I'm going to subtract 5x from both sides to move that to the left side. And this is going to cancel out. And this is also going to cancel out. So we're left with negative 3 is equal to positive 14. This is a false statement. That is not a true statement. Negative 3 is not the same as 14. Therefore, we have no solution. Okay, there's no number for x that will make this work. Okay, and that's the idea. Okay, one last problem. Okay, we want to create a linear equation with no solution. So we're going to start with the statement in the form of a equals b, and this is a false statement, okay? So watch what I'm going to do. I'm going to say that 4 is equal to 6, okay? That's a false statement, okay? Now, I'm going to add the same variable term to both sides. So now what I'm going to do is I'm going to add, I don't know, 3x to both sides, okay? And so what we end up getting over here is we're going to take 3x plus 4 is equal to 3x plus 6, okay? And then we're going to add the same constant term to both sides, okay? All right, so essentially from here, you have created an equation like that. Now, we could take this a step further, okay? And we could add like another, add a 7 to both sides, okay, to make it even more so. And so we'd get 3x plus 11 is equal to 3x plus 13, okay, to make it even more so unrecognizable from what we started with. And then we go from there, okay? And we could solve this, okay, and verify that we have no solution, but I'm not going to do that. So that's it for this video. Hope you enjoyed it, and we'll see you in a bit. Thanks a lot. Bye.